Hey everyone, I am SV Krishna and I am a sophomore at the Department of Electrical Engineering in IIT Madras. So today I'll be taking the session Introduction to Electronics on behalf of iBoT Club. So let's begin. So what is electronics and a robot about? Electronics and robotics works through a simple cycle of sensing, processing and output. So when it comes to robotics itself, we can mainly divide it into three verticals. The first one is software, the second one is electronics, and the third one is mechanics. So in this cycle of input, processing, and output, there are several aspects. So when it comes to input itself, we can use either digital or analog inputs or use proper sensors. When it comes to processing, we use microcontrollers with uh, pre-programmed code which runs continuously with the software. And whereas when it comes to the output, we take decisions and display them using controlled output parameters. The thing is, mechanics covers output part in more detail, whereas software part covers processing part in more detail. But when it comes to electronics itself, it deals with all three of these: input, processing, and output. And that is why I also told that the soul of robotics is electronics. So now I'll show you some electrical components. While explaining about all the electrical components on my screen, I'll broadly divide them into five categories. First one would be the ones dealing with inputs. These will include switches, which can give us digital inputs like 0 or 1, or false or true, or low or high. And then we can come to potentiometers, which can give us analog inputs. There are several types of potentiometers such as trim pot and normal potentiometer. And then we can also use sensors. Sensors come directly or in modules. We have a light dependent resistor here, and we also have several modules such as IR sensor module, ultrasonic distance sensor module, and some other sensors. When it comes to processing of information, we can have integrated circuits like this one, which have fixed functionality, or else we can have microcontrollers which can be programmed using softwares like Arduino IDE using C programming language or other tools. Now, when it comes to the outputs, we can display outputs using simple physical changes such as blinking of an LED or buzzing of a buzzer. But we can use more sophisticated outputs such as 7-segment display or other LCD display or matrix display. Or else we can also do physical changes using motors such as the one to the left in yellow color. All of these have different functionalities and I'll go over these in detail afterwards. The fourth category would be the assembly of our circuit itself. This is not explained in this way, but for simplicity, I'll put perf boards and breadboards into this category, which we use for assembly. And the fifth category would be the remaining accessories. These would include resistors, capacitors, and diodes and other components which we use. Okay, moving on to our next topic, sensors. Sensors are devices that allow robots to detect physical changes in parameters such as light, distance, or temperature. Now, if we talk about sensors in a bit more basic manner, let's talk about inputs. Now, when we talk about inputs themselves, there can be several parameters. We can talk about switches, which can give digital inputs, which can be either high or low. Or else we can talk about other inputs via potentiometers, which give an analog reading value, which is also a numerical value. It is not true or false, but a decimal value between two values. In another way, it's a range of values. whereas our typical sensors themselves consist of either direct components or consist of sensor modules. Now we'll talk about this in a bit more detail one by one. Now talking about switches in detail, when it comes to a generic type of switch which we come across in our daily use, there are four major categories within it. It is SPST, SPDT, DPST and DPDT. I'll explain these in detail. This basically refers to how many circuits or like poles they have at the end and how many connections do they make usually. And apart from these, there are other subcategories of switches. These would majorly be button switches, toggle switches, and dip switch. And when it comes to button switch, there is a similar subcategory called tactile switches. They can be considered together, but here I'll be referring to them in difference. And these two have two types of switches within them. One is self-return and one is self-lock. These both have different properties. And apart from this, we also have a slide switch. A self-lock switch retains its position after a change is made, whereas a self-return switch comes back to its original position once the physical change is over. Now, talking about switches in detail, let's go over the four generic types of switches which I told you about. Now, first of all, coming to SPST and DPDT, these are the two switches which I have with me right now, which look as follows. Now, what exactly are these short forms? So, the first two letters in all four of the categories, which is either SP or DP, refers to the number of poles. Now, these poles will inform us the number of circuits which we can individually control in the switch. Now, when it comes to a SP, we either have two poles or three poles. When it comes to DP, we either have six poles or three poles. Now, coming to the second part of each switch, it refers to the number of throws. Now, throws would explain the number of variations for a given circuit. This might sound a bit weird, but SPST means that we only have two poles and we have one circuit which breaks or connects. When we come to SPDT, it means that we have a single circuit which has two variations. One case where we have in a way the left hand side of the circuit connected and in the other way right hand side. Now, the DPDT and DPST, this simply means that we have two similar circuits beside each other, which would mean that a DPST switch basically functions as two SPST switches which are stuck to each other such that their both positions are interrelated. That would mean that either both circuits are on or both circuits are off. Now we can have a better idea of an SPST switch seeing the initial switch, but when it comes to SPDT, it is similar to the slide switch I have here right now. As you can see, the slide switch has three poles, and when the slide switch is to the left two poles are connected, and when it is to the right, the extreme poles are connected. And this might even differ based on the type of switch we are using. Now moving on to the button switches. Button switches are mainly of two types are of two types. These are self-lock switches and self-return switches. Now here I have both of them. When it comes to a self-lock switch, when we push it, it retains its position. But when it comes to a self-return switch, it comes back to the original position. They have their different uses. And there are similar smaller versions which can be called as tactile switches. Here I have different tactile switches. Now, even in tactile switches, there are different types of categories which I told you before: SPST, SPDT, DPST, DPDT. These switches are common across all categories. Even in a toggle switch such as the one I have right now, this toggle switch itself is a SPDT. And there are all four categories available in the toggle switch also. And when it comes to a dip switch is basically an array of SPST switches where we can individually control each of the switches. And last but not the least, discussing about the slide switch, it is similar to what I showed before. A slide switch in theory can be explained as a toggle switch in a smaller form factor. Now, going back to potentiometers, let's discuss about analog inputs. Now, there are several types of potentiometers. The first one would be the generic potentiometer, which we usually use in general cases. The second would be a linear potentiometer. The third would be a preset potentiometer. And the fourth would be trimmer potentiometer. Now, a potentiometer has three terminals. Two of its terminals are suspended across a ground and a VCC. And in between, we have a wiper terminal which moves across a metallic strip which is connected to the other two terminals. Hence, when this wiper moves, it can take any analog value between 0 and VCC. Hence, using a potentiometer, we can give ourselves an analog input value. Now discussing about potentiometers in detail. So first of all, coming to the generic potentiometer, we have a ground and VCC terminal, and in between we have a wiper terminal which is connected to the knob outside. Now this knob can rotate 270 degrees, and this knob is attached to the wiper, hence the wiper can give out any analog reading between ground and VCC. Now, these potentiometers can also come in other shapes and sizes based on their uses. Now, as you can see, here I have a smaller potentiometer. This is either called a trim potentiometer or a preset potentiometer. These are often listed as both on different websites for selling. So as of now, I'll be treating these as the same. Now the trimmer potentiometer has multiple turns in it. So due to this, we can fine tune our VCC or the wiper value better for any other usage. For example, here I have two different modules which are used for sensing. Okay, basically I have two different sensor modules, and you can observe that there is a preset potentiometer on both of them. These are used to fine tune the output values of these two sensor modules. Hence, these in a smaller form factor are also very important. Whereas this second potentiometer or a preset potentiometer doesn't have multiple turns and cannot be fine-tuned very much, but also has a similar purpose. One common usage that we would see is like powering the LCD screen's background display. Going to next subtopic, sensors. So if you want to go through sensors in more detail, feel free to pause the video and go through them or Google them. So when it comes to sensors themselves, we can broadly divide them into two categories. One would be proper modules and the other would be direct components. When it comes to direct components, we have to manually map the values to some required physical parameter in SI units which we want to measure. It's not always given that way, and also fine-tuning the values using potentiometers is not possible. So such sensors, for example, would be IR sensor module, or okay, the LED mounted on a IR sensor module. Some other examples for these would be also light dependent resistor or a DHT11 soil moisture and temperature sensor. Now, when it comes to modules themselves, modules often come with a potentiometer mounted onto them, and they have also sometimes better libraries. And they are more easier to handle as you already have a fixed item. Now, these modules already have components which are mounted onto them. So, for example, let us take an IR sensor. The same IR sensor can be mounted onto a module and can be paired up with a IR LED, and this would in a way give us an object sensor. Or for example, take a light dependent resistor and it will be used as a light detection module. Now, discussing about sensors themselves, first of all, let's talk about individual components. So, here to my left are the components which come directly. Now, first of all, to have a better comparison, let's compare this module here with the direct components. So, as you can see on the left, we have a IR LED on both. Okay, on the module as well, and to the right we have an IR sensor. So what is the difference? When we deal with we deal with the components directly, we have to manually encode like the each property that the module does on its own. So when we simply talk about the module itself, we either get a high or low based on IR detection values. But when it comes to the components themselves, we have to manually turn on the LED. Then if we get a high, we have to register it as a high, and if we get a low, we have to register it as a low for the individual components output. And similarly, we have some other sensors which also come in both ways, direct components or modules. So here I have a soil uh, capacitance-based soil moisture level sensor, a DHT11, which is a moisture and temperature sensor, and a light-dependent resistor. All three of these are direct modules, direct sensors. On other hand, here I have an IR sensor module, and I'm I'm not exactly sure how I'd like to classify the ultrasonic distance sensor, because I have never seen the component alone, but okay, let's classify this as a module because we can also directly handle the component. So this would be the key difference between a sensor's component and a sensor module. Now discussing about one final input module, I'll show you a joystick module. Now, what exactly is a joystick? Now, if we remove the cap of the joystick, we can observe that we basically have a stick which is connected to two potentiometers. So, with the help of analog input of this potentiometer, we can get a reading value which can be mapped to the x and y axis. And similarly, this x and y axis value can be mapped to the angle if required so, and we can also observe that there's a button which is attached to the stem of the joystick module. So basically by using two potentiometers and one button, we can get a very good input value reading module. Moving to our next subtopic, what is a microcontroller? So microcontroller is basically a small computer which can take decisions based on input parameters. So it does processing. Now processing can be a bit raw where I can simply have a logic in place. For example, I can have a NOT logic while monitoring sunlight to turn an LED on or off. Now here I'll check the sunlight parameter, and when it goes down, my LED parameter will go up or high. Or else I can have a pre-programmed Arduino which will be monitoring the sunlight and take action. In both cases, I am using an IC. Now, what is an IC? IC is basically an integrated circuit. It doesn't have much depth to it, but it just means that I have a very small circuit. It can be a simple NOT gate, or it can consist of a framework which has the ability to be self-sustainable and have the ability to be reprogrammed and have reusability. So it can be a simple NOT gate, or it can range to an ESP32. It just means that it is a really small circuit. Now, what exactly do I mean by logic gate based processing? Now, this would just simply mean that I have a fixed logic gate or array of logic gates in place to take my final decision. Suppose I want to check two parameters. So in this case, I would basically use an AND gate or a NOT gate wherever required. So this would mean that my logic is hard coded in a given IC and it is not reprogrammable. It has a fixed decision. Like we have a fixed truth table and we cannot reprogram it. Now, what is a microcontroller? A microcontroller is a extremely complex IC which can be reprogrammed. It is sustainable to itself and it takes decisions just like a very small logic gate IC. Now it basically means that I have a very good reprogrammable IC which has its own memory and which can also monitor values, take decisions, and give outputs. Now you would have a doubt, what is a microcontroller board? Now, a microcontroller board is basically a big board with several pins, ports, etc., along with a microcontroller chip on it. So, these pins and ports allow us to use the microcontroller board in a more effective manner. So, it is basically an extension to the microcontroller, and we can play around and mess around with it. Now, physically discussing about ICs and microcontrollers, basically to my left is a simple IC. It has no extra board. Now, as you can see, very, s- it has a very small stature and it has a given logic fixed to it. So in this case, I would simply call that this as a digital logic gate or an array of digital logic gates. So this is a L293 motor driver which basically drives and turns motors on and off based on inputs given to it. This is a little bit fancier L298 motor driver. This consists of an IC and a board which is used to control it more effectively. Now this is an Arduino Uno R3. If you look at it, you can observe that here I have a long IC on this board. Now this is the microcontroller. It is basically a very good IC. This is self-sustainable, which would mean that it has its own RAM, its own memory, its own clock, and yeah, basically it's self-sufficient. So we can deploy it by programming it with some code. So what exactly is this fancy board around it? This is what I would call a microcontroller board. Now we have our microcontroller, but we need some extension to it to hook it up to our laptop. So for example, I have a port here which I can connect to my laptop and program this. And then I can directly connect jumper cables to all these holes here. Now jumper cable is basically a wire with a hard end and has compatibility. They are standardized cables, so I'll introduce them later. So this is what basically a microcontroller versus IC would be. Every microcontroller is an IC, and IC could range from a simple logic gate or an array of logic gates which would be used to take decisions to a very good complex microcontroller. Going to our next subtopic, microprocessor versus microcontroller. Now this comparison is very confusing and like usually these are confused with respect to each other, but the gist of it is that every microcontroller has a segment which has to be a microprocessor, and I'll explain it to you in a bit more detailed manner. So let's do a breakdown. Now, first of all, how would we discuss about it? So now a microcontroller is basically a small controller and a microprocessor is basically a small processor. Now, a bit more generalized example would be when discussing with respect to a CPU, the entire unit. The Intel processor is what is a processor, whereas the entire setup on the motherboard, the processor itself, the RAM, the memory, and other things make up the CPU or the controller. Because it has RAM, storage, processor, etc., it can individually control things. Whereas a processor is just like a strong calculator. So a controller, it takes inputs, it takes decisions with maths and does the processing. Whereas when it comes to a processor, it's a very strong and good calculator because it does a large number of calculations or with a very high speed. Now we could say that a microcontroller has a processing unit in it. Hence, we can also give examples such as for microcontrollers, it would be ESP32, STM32, and an 80 mega microcontroller. Whereas when it comes to microprocessor, it would be Intel or okay, Intel usually makes processors, and when it comes to microprocessors, Snapdragon within mobile would be a good example, and they cannot work independently. Moving on to the next topic, motors and motor drivers. So what is a motor? A motor is basically a component which generates rotational motion from electricity. So let us talk about different type of outputs which we have. So first of all, we can have LEDs, we can have buzzers, and then we can have motors. So within LEDs, we can have an IR LED, which is a bit different. We can have normal color LEDs. Yeah, and we can have 8 by 8 matrix LEDs, which is a matrix. We can have common cathode and common anode RGB LEDs. They basically have four terminals. Then we can have buzzers. Buzzers are of two types, passive and active. It depends on the type of supply of current which we give to them to buzz. And as of LEDs, they come in several shapes and sizes. Back to motors. Motors, first of all, we have a normal motor which we use everywhere. Then we have a servo motor, and also in LEDs we have LCD display, liquid crystal display. Okay, back to motors. We have a high torque motor, we also have a mini motor, we have a high speed motor, and we also have pumps which basically have a motor inside them. Now basically motors are used for physical movement, so we use them a bit more compared to other components. So let's discuss about motors in detail. Now basically here current gives us motion. So for a given power we can have different types of output. First of all, we have a generic motor and a mini motor. So these are small and have medium speed and medium torque. Now we have a high torque motor. Basically, when we have a generic motor, we can have it geared up such that it produces high torque but low velocity. Now we can also have high speed motor. A high speed motor would be such that its torque would be low but its speed would be high. So torque into speed would be power output. Hence, for a given voltage and current supply, we would either have high torque, low speed, medium torque, medium speed, or low torque, high speed. We also have servo motors, which can go to a given fixed angle based on an analog input. And then we have a stepper motor which can displace itself and with respect to some angle. And then we have a geared motor. These are the major types. Okay, now talking about these electrical components which give outputs or do physical changes. First of all, let's just start off with the less important ones. When it comes to LEDs, they come in several shapes and sizes. I can just make a new cover and here we have a new type of LED. So we can basically say that LEDs emit light. So we can have IR LEDs, UV LEDs or visual spectrum LEDs. And also I can have different colors of LEDs within a same crystal cap or plastic cap. So that would give me RGB LEDs. So at the bottom left, you can see that there are two LEDs with four terminals. So for one I have common cathode and for one I have common anode. And the other three terminals are directly connected to the given specific LEDs. Now I also have a laser module, and we can have more sophisticated output via segmented displays. So here I have 7 segment display and a 8 by 8 LED matrix. Now LED matrix are useful even to make games. And then here we have a normal liquid crystal display which can be used to easily display words, numbers, etc. It comes with pre-programmed libraries which makes our work way easier. Next, we have buzzers. Buzzers are active or passive. I have them on a breadboard. So the difference is that a passive buzzer and active buzzer, they have different electrical inputs. One would buzz for a AC signal and the other for DC. Where the active buzzer requires a DC input and passive buzzer requires a AC input. Next, going to motors. I don't have a normal generic motor with me, but to the top right, we have a big normal motor, and beside it is a miniature motor. Now, when we take a normal motor and we add a lot of gears to it, such that its speed reduces, but it takes in the same current with a given voltage supply, we get a high torque motor. Now, high torque motors are used to drive bots in a way, it is such that they can carry more load and move forward, where acceleration is not the more required factor. Then we have a servo motor. Now servo motor has three terminals. One would be ground, other would be VCC, and other would be data or angular input. And based on the angular input, it goes to that value. Now coming to the other motors which I have, here I have a high speed motor, and these motors are usually used in drones and they are unidirectional. They have only one direction. And above that is a guide motor. It has ton of outer gears and which makes it high speed and low torque. And then we also have a generic pump. Now, when it comes to a RC, we might also think that how are we supposed to reverse a given motor? Like, do we use two digital pins in an Arduino or do we connect the same battery in opposite? So it is what I'll be covering next, the H bridge. So what is an H bridge? H bridge is an effective way to reverse the polarity of voltage supplied to a motor. Now I'll give an example for this using a DP-DT switch. Now let us assume we have a DP-DT switch. First of all, like I explained, the DP-DT switch is two SP-DT switches which are beside each other. Now let us assume the DP-DT switch to be as follows, where I have connected two terminals of the individual SPDT switches to VCC and ground respectively. And let us assume I made a cross connection such that the other two terminals of the DP-DT switch are inverted. Now, when I connect my motor across the other two terminals, for one orientation, I'll have the circuit connected in such way that I'll have clockwise rotation and current is supplied from VCC to center pole to motor to center pole of other SPDT switch to ground. Now, when I turn the switch the other way, I'll have the polarities interchanged, which is supplied to the motor, and I get anti-clockwise movement. So this is how I can simply express the working of an H-bridge using a DP-DT switch. But in real life, in place of a DP-DT switch, we use a transistor setup along with capacitors because motors while changing their direction will consume a higher amount of current than usual. So due to this, there might be a sudden spike in current consumed, hence we require capacitors also. A DP-DT switch would be nice to have in a completely manually controlled remote control car, but it is better to have a normal H bridge such as L293 or L298 while using Arduino. I'll explain about it by showing the components. 1 minute. Okay, so this is how I would represent my entire circuit where the two boxes are the two switches. Now, this is a L298 motor driver which I showed you before. So basically this has a L298N IC which is mounted onto a circuit board, and we can observe that there are capacitors on this, and we also have header pins, and this motor driver also has a voltage regulator. So it takes a higher voltage supply in and supplies a 5 volt VCC which can be hooked up to our Arduino. So this is something which we usually use in our projects. Going to our next topic, Arduino Uno. So as I explained before, Arduino Uno is a microcontroller board which runs on a 80 mega chip. It itself is not the microcontroller but is an extension. While checking the ports on Arduino Uno R3, we first see that there are several header pins. So we observe that there are analog pins and digital pins. So both analog and digital pins can be used as GPIO, general purpose input output. This means that we can read digital values and write digital values from both of these pins. But whereas when it comes to analog pins, they can be used to read analog values, and whereas when it comes to digital pins, some of them which are marked with a hyphen can perform pulse width modulation to generate analog values. So let us check out other ports on Arduino before proceeding to check how pulse width modulation happens. Here we have an Arduino Uno R3. We observe that to the left we have power pins and analog in pins. So these are GPIO pins which can also read analog values, and we can see that there are digital pins to the right which are also general purpose input output along with some pins marked as PWM with an hyphen which can generate analog values. We also observe that there are some capacitors, additional header pins in the middle, a reset button, a power port, and also a port which allows us to connect our Arduino to the computer. Okay, so let's understand how pulse width modulation works. So pulse width modulation itself is a very easy concept. So we would initially assume that the Arduino Uno would have some internal potentiometer which would give us an intermediate value between VCC and ground. But that's not how it works, because in between, suppose we are using an LED which requires some minimum voltage to work. This will lead to irregularities. Hence, rather than projecting an intermediate value, we turn the digital value on and off very quickly. So suppose we want an intermediate value of 2.5 volts. In a clock cycle, which is very less in time value, we turn on the digital value for 50% of the clock cycle and turn it off for 50% of the clock cycle, which would result in an average voltage supplied of 2.5 volt. So this is how analog output works in pulse width modulation pins of Arduino. And this is where I'll be concluding my session today. So after this, you can check out other videos on our channel related to this so that you can understand about electronics more. So thank you for attending this session.